Live free or die. Live free or die. Live free or die.
Welcome to Hardfire. I'm Ronald Wick. We're back with the third installment of our series with Ryan Mackey, a research scientist at the NASA Jet Propulsion Laboratory. Tonight we're going to discuss the collapses of the buildings in the World Trade Center complex. First, a brief commercial. This is the official Hardfire mug that you see me sipping from. It is both hard and strong. If you drink wood alcohol, it won't disintegrate. It's heavy enough to use as a weapon, and we will sell it to you. Well, we will sell you my tie and shoes, but the mug is worth having. So visit hardfire.net, click on the mug. If you buy 5 or more, I suppose I'll have to deliver them personally. Back to Ryan Mackey. Ryan, you want to talk about the collapses of the towers, why the buildings fell as they did. The first question, the question that everybody asks is, was there anything unusual about the way they fell, or was that the only way they could have fallen?
Well, it depends on what you mean by that. The collapses were certainly unusual, but you need to keep in mind these were unusual structures, and what happened to them really doesn't have too many exact analogs in history. If you think about their construction, and you think about the method in which they failed, then it actually does make sense. And as we discussed in previous shows, I'm not aware of any of the very many papers on the topic that find even the slightest bit of mystery about the way they came down. But what I'd like to do is come up with our own model so that we can start thinking about this on our own, see if we can become comfortable with the mechanism of collapse. So if you're ready, let's go ahead to slide 2-1. Very briefly, what is a model? This concept of a model keeps coming up in the scientific discussions. And again, a model is a simplification. What's important about a model is 2 things. First of all, it gives us a way to repeat the problem. It's what we call a reductionist approach, where we break off a part of the problem that we think is important and we focus on it. The other thing that's important is that the model, in order to be any good, has to behave the same way as the real system. So it should have more or less the same physical mechanisms, and it should scale properly. And this is one of the things that confuses a lot of the people in the truth movement. I want to go through this really quick, so let's jump ahead to slide 2-4. If you can see this, there are a couple of pictures here. These are actual models that have been produced by the truth movement in an attempt to claim that the collapses shouldn't have happened that way. Now, I shouldn't have to explain this, but these are not good models. The materials are wrong, the methods of connection are wrong, the size is wrong, the scale is wrong. And it shouldn't be any surprise that they don't behave the same as the real collapse. Something this size, it's quite possible for something to topple over, or kink, or not collapse at all. But because these aren't good models, they really don't tell you anything. It is possible that even though it's not a good model, the real thing could fail this way. Or it's possible the real thing could fail in a completely different way. And if you don't go through the math, you'll never know if your model is predicting anything or if it's just causing more confusion. So let's jump ahead a little bit more. Let's go to 2-5. We're going to make our own model, and our model is also going to be very, very simple. We're going to leave out a lot of important things, but the difference between our model and those models is we are going to go through the math, and we are going to make sure that everything works out. So in our model, we're just going to assume we have a bunch of different floors that have a given mass and are spaced by a given distance. We assume that the strength required to break through the columns and down to the next floor is some fixed quantity. And this quantity is equal to the yield strength times the displacement of the steel before it breaks. We need to keep track of the number of floors we're talking about. We need to keep track of gravity, because in our model, gravity is the only thing that's providing energy for this thing to collapse. And there's a long list of things we're leaving out. Go ahead to 2-6. So I'm going to diagram this model. And if you don't diagram the model, you really can't explain it to other people. This is good practice. Our model has 3 steps. The first step is you've got some large object that starts with some velocity and it falls some distance, and it accelerates according to gravity. So what we can do is work out the equation for energy of this object as it falls. That's that one equation there. I start out with some kinetic energy, I add a gravitational contribution, and I wind up with the new velocity, the new kinetic energy. So that's the first equation in my model. Now let's go ahead to 2-7. I apologize if I'm going too fast. I want to leave some time for discussion.